Hello friends, welcome to Innovative Shiksha. So today I bring to you the next video in the important MCQ series. So today's video will be based on class 11 physics chapter number 2, that is units and measurement. So today's video will be based on the topic applications of dimension analysis, because we have already covered the concept of dimension, what is dimension and how we can find the dimension of physical quantities. These type of things we have done in last video. If you haven't checked the last video, please go to the last video and check out what are the concepts and then try to solve these questions. So let us start with today's MCQs. So before trying to solve the question, please try yourself and then check out what are the answers. So let us come to the first question. So the first question says, if x equals to at plus bt square, where x is the distance traveled by the body in kilometer while t the time in seconds, then the units of B are. You have four options. Option A, kilometer per second. Option B, kilometer second. Option C, kilometer per second square. And option D is kilometer second square. So you have given an equation where in this equation x is the distance. So x is the distance which is in kilometer and t is the time which is in seconds. So what you have to tell, what is the unit of B? So you have to tell what is the unit of B. So if you have studied the concept of dimension, in the concept of dimension we have studied a very important principle. And what is that principle? The principle of dimensional homogeneity. So according to the principle of dimensional homogeneity, we know that we can add or subtract similar physical quantities. For example, let us suppose we have a physical quantity velocity and we have a velocity, let us suppose v1 5 meter per second and another velocity 3 meter per second, right? So if you want to add these two, we can add very easily v1 plus v2, that is 8 meter per second. Why we can add these two quantities? Because these two quantities are in similar physical quantity, but we cannot add. For example, suppose we have a physical quantity velocity 8 meter per second and force 9 Newton. Okay, so we cannot add this velocity with this force. Why? Because these two quantities are not in the same physical quantity or they are not in the same dimension. That is why we cannot add or subtract this type of quantity, but we can add or subtract this kind of quantity where the quantities are in the same dimension, right? So this is the principle of dimensional homogeneity. So we are going to use this principle of dimensional homogeneity and try to solve what is the answer or what is the unit of B, right? So let us try to solve this particular question. So this particular question will be solved very easily if you apply the concept of principle of homogeneity. So we are going to apply. So let us try to solve. So we are writing this equation here, x equals to at plus bt square, right? So we have to find what is the dimension or what is the unit of B. So applying principle of dimensional homogeneity, we can say the dimension of x and the dimension of this quantity will be same. Okay, then what we can say, we can write this as B equals to x upon t square. Now we can substitute the values of x and t in its proper units. We will get the answer. So let us try to put the value. So for x, we have x is the distance which is in kilometer. So for x we can write kilometer and t is the time in seconds. These quantities are given in the question, right? So t is the second, so it will be second square. So kilometer per second square will be the correct answer. So let us try to match with the options. So what are the options? Option number A is not the answer. Option number B is not the answer. Option number C is the correct answer because kilometer per second square and kilometer per second square. So these two options are matching. Therefore, the answer would be option number C. So for question number 1, the option will be option number C. So option C is the correct answer for question number 1. Fine. So let us start with the next question. So next question says, the unit of surface tension in SI system is. So what we have to tell? Unit of surface tension in SI system. Please focus this point, SI system, because we have different system like CGS system, MKS system, SI system. So we have to tell as SI system. So you have four options. Option A is dyne per centimeter square, B Newton per meter, C dyne per centimeter, D Newton per meter square. So out of these four options, you have to choose the correct one. So let us try to find what is the unit of surface tension in SI system. So if you know what is the definition of surface tension, so we can write here surface tension can be defined as force per unit length, right? So S equals to F by L. So we can write the units of force and length, and this will be the unit of surface tension, right? So let us write F. For F we know the unit of F is Newton, and the unit of length is meter. So here we have Newton per meter is the unit of surface tension. So please match with the given option and let us find what is the correct answer. So let us match. Dyne per centimeter is the option A, which is not correct. Newton per meter, here Newton per meter. Therefore option number B will be the correct answer. So for question number 2, option B will be the correct answer. Option B is the correct answer for question number 2. Okay, so let us come to the last question. Last question says a suitable unit for gravitational constant is. So we have to find suitable unit for gravitational constant. You have four options. Option number 1 says kg meter second inverse. Option B is Newton meter inverse second. Option C is Newton meter square kg minus 2, or kg meter second inverse. So you have four options. Out of these four options, we have to choose what is the correct one. So let us try to solve what is the unit of gravitational constant. So if you have studied the gravitational force, you know that F equals to G m1 m2 upon r square, where m1 and m2 are the masses and r is the distance between the masses. Okay, and G is the gravitational constant, F is the force or gravitational force, right? So what we have to find? We have to find the unit of gravitational constant. So we can write this equation like this also: F r square m1 m2. Now we can substitute the units of these quantities and we will get the unit of capital G. So let us substitute. So for F we have unit Newton, for R we have unit meter square because it is a square, R square, and here also we have masses m1 and m2, therefore it will be kg square. Or we can write this equation like this also: Newton meter square kg minus 2. Now we can match our answer with the given option. So let us match which is the correct answer. So option A is not the correct answer, option B is not the correct answer, and option C Newton meter square kg minus 2. So that is why our answer will be option number C, because this and this are same, therefore the answer for question number 3 would be option number C. So we have option number C is the correct answer for question number 3. Thank you very much.